We will be looking now at the normal approximation to the Poisson distribution. Under which conditions Poisson distribution can be approximated by a normal distribution. To get an idea when can we approximate a Poisson distribution by a normal one, you are going to watch a short movie where the graph of Poisson of lambda is shown. So my distribution x is Poisson with lambda. In this case, we have Poisson of 7, so that's probability of x being 0, 1, 2, 3, and so on, 5, 6, 7. So see around, that's a mode, around 7. And in this case, we can't really approximate it with a normal distribution. It doesn't look like one. And we are going to see at what point we can do that. So as we change lambda, see it's not a normal distribution, and it's considered that at around 15, the shape is similar to a normal distribution. For all lambda bigger than 15, it is very, very close to a normal distribution. Ignore the dotted lines that show the cumulative distribution for Poisson. Intuitively, on the previous screen, we saw that if x is Poisson of lambda, and if lambda is bigger than 15, then x can be approximated by a continuous distribution which is normal. I put an xc because the normal distribution is continuous. Now, what are the parameters of the normal distribution? The mean of the normal distribution need to be the same as the mean of the Poisson, but we know that the mean of Poisson is lambda and the variance of Poisson is lambda as well. So normal will have mean lambda and variance lambda. When I approximate the Poisson with a normal, I need to involve the continuity correction concept. Let us exemplify by this question. If x is Poisson of 20, and you see here the image, I want to calculate probability of x being between 15 and 38, 15 included, 38 excluded. In my case, lambda is 20, which is bigger than 15. Therefore, I can approximate x with a continuous distribution, which is normally with the same mean and variance as the Poisson distribution. Now, when I approximate a discrete distribution with a continuous, see, I need x to be between 15 included and 38 not included. So if I want to include 15, I need to start from 14.5. And I need to go up to 38 and not include 38. Therefore, I will need all this interval up to 38 not included. So 37.5 up to this point. Therefore, that probability that I'm required to find is the same as probability of x continuous being between 14.5 and 37.5. And see, then in this interval, I include 15 and I don't include 38. Now I use the normal distribution and what I know from before about it. Okay, so let me remind you that I will need to standardize in order to find this probability. And I use the formula z equals x minus mu over sigma. So I go from x to z, x minus mu over sigma, x minus mu over sigma, and I get this probability. And now, remember on the normal distribution, I need to find standardized normal. I need to find probability of z being between minus 1.2298 and 3.9131. So it is all this area. Take away this area, which is what I wrote here. The first one is pretty clear because it's phi of 3.9131. And for the second one, this area here is the same of the symmetric area on the other side. So it's 1 minus phi of 1.2298. Therefore, my answer will be phi of 3.9131 plus phi of 1.2298 minus 1, which will give me. So that's revision from S1. I use the tables, or you can use your calculator, and that's below, it's the final answer.